All right, well, welcome to our first edition of sixth grade math notes on video. We're going to be looking at chapter 1.1. This deals with whole number operations, kind of getting our feet wet to what we're going to be doing this upcoming year. So if you go ahead and have your packet ready with you, we're going to do some problems together. You're going to try some problems on your own, and then we're going to see how you do. And take your time with this. You can rewind. You can watch things over. You can do whatever you need to help you be the most successful person as possible throughout these online video notes. Okay, so we're going to go ahead and move on. All right, so recall there are four basic operations when we're doing our math problems. You have addition, subtraction, multiplication, and division. Again, you can see these, some of the words, for like addition, you may run across the word sum. Subtraction would be difference, multiplication would be product, division is quotient. Those are the words that would be in referencing the answer of an addition problem or the answer of a subtraction problem, so on and so forth. And then algebraically, writing the problem with the letters. You could have like a plus b for addition, a minus b for subtraction. For multiplication, a times b can be written with the x, or we're going to introduce a dot. You can use a dot for multiplication. Division, there's really three different ways you're going to see this. We can use the division sign with the line with the dot above and below it. It can also be written as a fraction, and then also with the little division bridge that you saw when you were growing up, okay, for like the long division. So let's try this first example together. And so you see it, the problem reads, the bar graph shows the attendance at a three-day art festival. What is the total attendance for the art festival? Now, right away, I'm seeing the word total right here, the total attendance for the art festival. That typically will mean I'm going to be adding. So keep that in mind. So what's the total attendance for the art festival? So you want to find the total attendance for the 3 days. In this case, the phrase total attendance indicates you need to find the sum of the daily attendance. So we're going to go ahead and line up the numbers. So we have the 2,570, the 3,145, and the 3,876. We're going to add these together, as you can see right here. Line them up. So all the ones, the ones place are lined up, the tens place, the hundreds, the thousands, all those place values are lined up. We're going to add, and remember, like when we're adding the ones place, we have 0 plus 5 plus 6 is 11. Bring the 1 down, we carry the other one because we have 1 in the ones place, and then we have one group of 10, and so that goes over to the tens place. And we'll do the same thing here. We do 1 plus 7 is 8, 8 plus 4 is 12, 12 plus 7 is 19. We'll put our 9 down and carry a 1, so on and so forth. Hopefully you remember doing this from last year and probably the year before. And we end up getting a total of 9,591 people. Okay, for part B, what is the increase in attendance from day 1 to day 2? Okay, so we're looking at the increase. If I say I start off with 5, and then the next day is 4, and I say, well, how much did it increase over those 2 days? Well, from 5 to 4, you would know just right off the top of your head, well, it increased 4. But the bigger question is, how did you get the number 4? And we get that number 4 by subtracting, finding their difference. So when we're trying to find the increase, we're really going to find the difference. We're going to subtract. So we're looking at day 1 and day 2. We're going to subtract or find the difference between these two numbers. And when dealing with these whole numbers, we're going to find the difference by subtracting the smaller number from the bigger number. Okay, so let's look over here. We have 3,145 minus 2,570. Well, to start off with, we have 5 minus 0 is 5, which is easy enough. But then you'll notice, here, I'm going to do this to the side just so you can see it as well. So 3,145 minus 2,570. Okay, So to begin with, we do 5 minus 0 is 5. That one's easy enough. But then we have 4 minus 7. Well, that's not going to be 3 or negative 3. What we have to do is we're going to borrow. So that 1 becomes a 0. And you can put a little 1 here if you want to rewrite it as 14. But now it's 14 minus 7, which is actually 7. Now again, I have 0 minus 5, so I can't do that. So I'm going to have to borrow from the 3. The 3 becomes a 2, and that 0 now becomes a 10. So basically what I'm doing is, where that 3 is, it has the value of 10 of what's in the place value to the right of it. And so that's why I'm really going to take 1,000, I'm going to make it into 10 hundreds. So 10 hundreds plus the 0 hundreds is 10 hundreds. So 10 minus 5 is 5. And then 2 minus 2 is 0. So I have 575. So you'll see the increase in attendance from day 1 to day 2 is 575 people. Hopefully that makes sense to you. I'm going to go ahead and move on to our next example. So in this example, it says, a school lunch contains 12 chicken nuggets. 95 students buy the lunch. What is the total number of chicken nuggets served? Well, again, try a simpler problem. If I receive 2 chicken strips, and we'll say 20 people get the chicken strips for their lunch, how many are made? Well, we would say, well, it would be 2 times 20 is 40 altogether. What's all this is? It's a multiplication problem. So we're going to multiply. So we're going to have our 95 times 12. It doesn't matter which one you put on top. I'm going to put the 95 on top. The example puts the 12 on top. They both work the exact same way. So I have 95 times 12, and that's going to do 2 times 5 is 10, so put the 0, carry the 1. 2 times 9 is 18 plus 1 is 19. And then I'm going to go ahead and do the next line. So since I'm moving to the 1, it's in the tens place, I'm going to put a 0 so I can begin in the tens place. So 1 times 5 is 5. 1 times 9 is 9. I add them together, I get a 0. 9 plus 5 is 14. Carry the 1. That gets me 1 plus 1 is 2. 2 plus 9 is 11. So it gives me 1,140. And as you can see, that's the same answer they got over here. We just did ours a little bit differently. Okay? Hopefully that makes sense how we did this. At this time, you're going to try 1, 2, and 3 on your own. The estimation you can do in your head if you like, but I mean basically when we're estimating, we're going to make it as simple as we can. An estimation, the whole point of estimation is to make it simple. So for example, for number 2, it says 912 minus 799. That's the same thing as like 900 minus approximately 800, getting us 100. So you should expect an answer to be close to 100. That's what they mean by using estimation to check your answer. Okay, so you're going to try those 3. And yeah, that's it. So just try those 3 problems. And I'm going to pause it. And once you're done, I'm going to have you check my work. Okay? And to save you a little time, I'm just going to solve the problem. I'm not going to have you listen to my explanation. I'm just going to have you see show you all the work. Come see me in class the next day if you're not quite sure how I solved it. Okay? All right, well, let's go ahead and take a look at these 3 problems. I know I said I wasn't going to go through them, but I am. If you just want to see the final solution, you can kind of fast forward a little bit, but if you'd like to hear the explanation, I don't want to deny you of it, okay? So let's go ahead and look at each one of these 3 problems. So for number 1, we're going to be doing an addition problem. So I'm going to do 5 plus 2 is 7. 4 plus 8 is 12, so bring my 2, carry my 1. 1 plus 7 is 8. 8 plus 6 is 14. Bring my 4, carry my 1. 1 plus 1 is 2. So I end up with 2,427. For my next problem, I'm subtracting now. So I have 2 minus 9, which I cannot do. So I'm going to borrow from the tens place, make that into a 0, and then the 2 becomes a 12, technically. So 12 minus 9 is 3. I can't do 0 minus 9, so I'm going to borrow a 9 from the hundreds place, making that into an 8, and making this into a 10. 10 minus 9 is 1. 8 minus 7 is also 1, giving me a total of 113. All right. Finally, we're at multiplication. You could have put the 42 on top. Me personally, I like doing the larger number on top, so I put 118 up top. It does not make a difference. You get the same answer. So 2 times 8 is 16. Carry the 1. 2 times 1 is 2, plus 1 is 3. 2 times 1 is 2. And then I'm going to go ahead and do the 4. 4 is in the tens place. I'm going to put a 0 here. So I have 4 times 8 is 32. Carry my 3. 4 times 1 is 4, plus 3 is 7. And then 4 times 1 is 4. I'm going to go ahead and add now. 6 plus 0 is 6. 3 plus 2 is 5. 2 plus 7 is 9. 4 plus nothing is just 4. So I get 4,956. Hopefully that makes perfect sense to you. Okay? All right. Well, we're going to go ahead and move on to our next problem. This is example 3. I've kind of broken it up a little bit to fit on my screen. So yours goes straight down. Mine's going to go kind of across. Number 3 says, you make 24 equal payments for your go-kart. How cool would that be? My kids would love to have that. You pay a total of $840. How much is each payment? Okay, so we're taking our total amount and we're breaking it into smaller amounts, equal amounts. So what operation does that sound like to you? Well, it's not adding, it's not subtracting, it's not multiplying. It leaves us with division. So this is a division problem. We're dividing the big total into 24 equal parts. So we're going to divide 840, which I'll put right here, 840. We're dividing that by 24. Now, I know for you guys, division is something that we're not all fans of. So just take your time, try not to get yourself too worked up, and see how you do. When we're dividing, we're going to try to do some common sense. Estimating sometimes helps. Working with numbers that we're familiar with. Like, you may not be familiar with working with 24, but quarters you are familiar with. 25, 50, 75, $1, $1.25. I mean, we understand quarters. So work with the quarters and use that for estimation. So when I have 8, can you divide 8 by 24? The answer to that is no, so I put a 0 right there. But 24, can that be divided into 84? Yeah, because there's 3 quarters and 75 cents, and there's 4 and $1. So 3 would be our choice. So I'm going to put a 3 here. And I'm going to take my 3. And what I'm doing is I'm going to multiply 24 by 3. Now, I know some of you will want to multiply that on the side. I learned it a different way. I learned it to do this. 3 times 24, or 3 times 4 is 12. And then I put my 1 right here. 3 times 2 is 6, plus that 1 is 7. That's how I do it for myself. If you don't like doing it that way, you can do all the problems to the side. It's fine. Either way, whatever you're most comfortable with. I'm going to subtract now. 4 minus 2 is 2. 8 minus 7 is 1. And then I'm going to bring down the 0. I do suggest that you have a little arrow showing that you're bringing it down. I'm not going to take off if you don't, but it helps with organization and so you know what's happened every number in the problem. It's just something I do, and it saves me from making mistakes. I mean, that and making sure that you line up every digit in the correct column. That's, I think, is also really important to do. Neatness with these problems is incredibly important. Give yourself plenty of room to work. If you don't have enough room, get a bigger sheet of paper. Do not get in the habit of squishing your numbers together to make it fit. You make mistakes that way. All right, 120. Let's look at this. I have quarters. 1 quarter is 25, 2 is 50, 3 is 75, 4 is $1, 5 is $1.25. Now, you may say, well, 120 is less than 125. Yeah, but 24 is also less than 25. Let's go ahead and try the 5 just to see what happens. You know, the one thing with estimating is you can at least get yourself within 1 of being the correct answer. So we'll go for it. So 5 times 4 is 20. I'm going to get rid of that. I'm going to carry my 2. 5 times 2 is 10, plus 2 is 12. I can subtract, and I get 0. So I have 35, so I know each payment then is $35. Notice I wrote the work on my page, even though it's already written. I suggest you do it too. You learn through doing, so that will help you by writing down the problem as I did and showing it yourself, just so you can have that practice doing the example problem. Because otherwise, you just glance at a practice problem, it's not exactly helping you. It can, but it works so much better if you go ahead and run through the problem yourself as well. Take it from a guy who struggled at math when he was younger. It helps to do this, okay? So now, we're going to have a few problems ourselves to do. We're going to have all 3 are division problems. Remember that a division problem can be written with the line with the 2 dots. It can be written with the little division bridge, house, however you want to call it, that you're used to doing. And then there's also a fraction form. So all 3 of these are division problems. I want you to try them. I'm going to pause it. And when you come back, we'll see how you did. Okay? All right, let's go ahead and try out these 3 problems, see how we do. So, for our first one, we have 234 divided by 9. So, 9 cannot divide into 2, so I'll put a little 0 there. It goes into 23. Well, 9 times 1 is 9, 9 times 2 is 18, 9 times 3 is 27, so it goes in twice. So I get 18. I'm going to subtract. The 2 becomes a 1. I'm going to borrow and make that a 13. So 13 minus 8 gives me 5. Bringing down my 4. So I have 54. And I know that 9 times 6 is 54. So I'm going to go ahead and finish the problem out. My answer is 26. All right. This one's a little tougher, maybe. 58. You cannot divide 9 by that, so I'll put a 0 here. And 58 times 1 is 58, times 2 is more than 100, so it's going to go in 1 time. So I'll put my 58 here. I'm going to subtract. 8 minus 8 is 0. 9 minus 5 is 4. I'm going to bring down my 6. I know this is where it gets a little tougher. And so this is where we're going to have to do a little estimating. 58 is approximately 60. So we can do 60 times 1 is 60, times 2 is 120, times 3 is 180, times 4 is 240, times 5 is 300, times 6 is 360, times 7 is 420. I'm going to go ahead and go with 7 because 58 is less than 60. We'll try 7, see how it works. Hopefully you're understanding how I'm coming up with these numbers. Division can be really troublesome for some people. So try to get good strategies to help you pick numbers to, when we're doing our division problems. 7 times 8 is 56. So I'll put my 6 here. Carry my 5. 7 times 5 is 35. 35 plus 5 is 40. And wouldn't you know it, it works out. So our answer is 17. All right. Our last problem here, 105 times 84. Well, we cannot divide 8 by 105, so put a 0. Cannot divide 84, so put a 0 there. So 840. Well, let's just think about this for a second. 100 times 8 is 800. 100 times 9 is 900. So there's no way it's 9. So let's try 8 and see how that works out. That's a really bad 8. This probably won't be much better. Oh my goodness. I'm really bad at 8s. Let's try this. There we go. All right, so 8 times 5 is 40. Put my 0 here. Carry my 4. 8 times 0 is 0 plus 4 is 40. And then 8 times 1 is 8. That's it. My answer is 8. Not too bad. All right, we're going to go ahead and move on to our next problem. And let's go ahead and move there. So now, again, we're going to try one more problem, for you to try. I apologize for that. Find the quotient of 9,920 and 320. So now it's written in the word form. You're going to divide this. And again, it should be pretty easy for you to set up. You're going to set up as 9,920 divided by 320. Why don't you go ahead and give this a try? I'll check in with you in just a moment. Okay. Hopefully you've had enough time to do this problem. Let's go ahead and look at it. 320 cannot go into 9, so we'll put a 0 here. It cannot go into 99. And think about this. How many times can 320 go into 992? Well, 300 times 1 is 300, times 2 is 600, times 3 is 900, times 4 is 1,020, or 200. That can't be 4. So 3 is the best bet. We're going to do a 3 here. 3 times 0 is 0. 3 times 2 is 6. 3 times 3 is 9. We'll go ahead and subtract. 2 minus 0 is 2. 9 minus 6 is 3. 9 minus 9 is 0, so we're going to bring down this 0. And 320 goes into 320 one time. So our answer is 31. Pretty easy. I know it looks like a big problem, but actually that one is pretty easy. Okay, so when you use long division to divide whole numbers and you obtain a remainder, you can write the quotient as a mixed number using the rule, take the dividend divided by the divisor, and you get a quotient, that's the answer, plus the remainder, whatever number is left over the divisor, what you're dividing by, okay? So again, dividend is what you are dividing. This is what you are dividing. Oh my goodness. Dividing. Divisor, what you are dividing by. Sorry, English teachers. And then quotient is the answer, right? So you're going to do that plus the remainder, which would be whatever is left over after you subtract, and you're going to put that over the divisor. That's the number you're dividing by. So hopefully that makes some sense. It will make more sense, I think, when we try it together. So I do want to pause, take a moment, and let you know that this is a really long set of notes. Most notes are not this quick. Usually our notes are done like in 20 minutes. This one is a lot longer than normal, so don't freak out thinking, oh my goodness, notes are going to take forever all the time. Usually they're done in less than 20 minutes. This one just takes a little bit more time. It's a long set of notes. You can see it in your packet. The notes are typically like 2 pages long. This one's 4 pages long, about twice as long. So hang in there. You're doing a great job. We'll see how you do. All right, so in this problem, it says, a 301-foot-high swing at an amusement park ride can take 64 people on each ride. A total of 8,983 people ride the swing today. All of the rides are full except the last ride. How many rides are given? How many people are on that last ride? Okay, so it's saying that every ride was full. That means whole number answer. And then the last ride, it's partial. So the partial is going to be whatever is the remainder. That would be out of the possible of 64 people. That is how many people actually rode the last one. And then for all the other rides, it was the full 64 that rode it. Okay, so it's a division problem. We're going to take the 8,983, so 8,983. We're going to divide it by 64 because there's 64 people on each ride. Let's first begin by dividing. So 8 cannot be divided by 64, so I put a 0 there. 89, it goes in one time, so I put a 64 here. 9 minus 4 is 5. 8 minus 6 is 2. I have a remainder of 25. I'm going to bring down this 8, and so I have 258. Now, 64, that's a tough one. It's similar to 60. It's closer to 60, I guess, than it is 70. So we can use that at least to give us an idea. So 60 times 4 is 240. 60 times 5 is 300. So maybe it's going to be 4, although it's hard to say. So I'm going to go ahead and try 4 to begin with and cross my fingers it works. 4 times 4 is 16. Carry my 1. 4 times 6 is 24. Plus the 1 is 25. We lucked out. And I'm going to go ahead and subtract. I get 2, and the other ones cancel out. I'm going to bring down my 3, and so I have 20. Oops. So I have 23. Now this is a little confusing because you're thinking, well, 23 can't be divided by 64. We're done. That's not the remainder because I still have this empty space above the 3. So how many times does 64, or how many times can you have 64 go into 23? That's 0. So I'm going to put a 0 here. 0 times 64 is 0. 23 minus 0 is 23. This is the remainder. As you were told before, you're going to take the the remainder would go over the divisor. So you'd have an answer of 140 and then 23/64. That's what it would be based on what this told you to do, if I'm writing it as a mixed number. However, this is a word problem. It's a little bit different. It asked us how many rides were there where it was a full ride. So there were 140 times that this ride was given with a full capacity of riders. The last ride had 23 people in it. So there are a total of how many rides? There's 141 given, 140 of which were full rides. But there's 141 rides given with 23 on the last ride. Okay, I know it's a little bit tougher, but I think you guys are smart enough that you guys can understand that. So hopefully that makes some sense to you. You can also look at it from this standpoint. So let's go ahead and look over here. You have 3 problems, 8, 9, and 10. And you're going to have one more word problem, I believe, over here. The same type, it's the exact same type of problem as the example we did before. So you're going to do 8, 9, and 10, expect a remainder, and then write that one as a fraction. In fact, let's do number 8 together, and then you can do 9 and 10 on your own, just so you can see it one more time. So I have, for number 8, I have 6,096 divided by 30. And so 30 goes into 60. It goes into 60 twice. And that gets me 60. I subtract. I get a 0. I'm going to bring down my 9. And so I have a 9. How many times can 30 divide into 9? Well, it's going to be 0. So I'll put a 0 here. So now I'm going to bring down my, well, I'll do 0 times 30 is 0, right? So I subtract, I get a 9 left over. Bring down my 6, I get 96. How many times does 30 go into 96? Well, 3 times 30 is 90. So let's try 3. I get a 90. 6 is my remainder. So I have 203, and then I have 6 over 30, right? 6 over 30, which can be written as 1/5. So 203 and 1/5. Now on a test, I would probably take 6 over 30 and be fine with it, because at least you show me what you meant. However, if you're doing this on big ideas and they have like an online problem, it may not take 6/30. You may have to write it as 1/5. So understand you have to simplify it, okay? So I'm going to have you guys try 9, 10, and then 11, and we'll check in with you in just a moment, okay? Okay, let's go ahead and take a look at number 9 together. So, for this problem, we have 45,691 divided by 28. And 28 goes into 4 0 times evenly. It goes into 45 once. So I'm going to put a 28 here. Subtract. We'll make that 4 into a 3 and the 5 into a 15. So 15 minus 8 is 7. 3 minus 2 is 1. And I'm going to bring down my 6. 28 is close to 30, so I'm going to use that to kind of help guide me. So I have 30 times, 30 times 5 is 130. 30 times 6 is 180. And this is a little bit less than 30, so we're going to go ahead and go with 6. So 6 times 8 is 48. Carry my 4. 6 times 12, or 2 is 12. 12 plus 4 is 16. That works. Going to subtract. And the 7 becomes a 6, and the 6 becomes 16. So 16 minus 8 is 8. I'm going to bring down my 9. 28. So 30 times 3 is 90. So I think 3 will work. So 3 times 8 is 24. Carry my 2. 3 times 2 is 6. Plus 2 is 8. Subtract, I get a 5. Bring down my 1. It goes in 1 time. So 28. And the 5 becomes a 4. 1 becomes 11. So 11 minus 8 is 3. 4 minus 2 is 2. So that's my remainder, is 23. So I'm going to end up having 1,631. And I'm going to have 23 over 28. That's the answer to that one. I know, that one's a little bit tougher. You guys are doing great. Let's go ahead and try this, number 10. So I have 3,215. I'm going to divide this by 430. And let's see what happens. I'm going to use this color. All right, so it goes in 430 cannot divide into 3. It cannot divide into 32. It can't even divide into 321. So we're going to divide it into the 3,215. So again, I don't know. We'll try 400 and do it this way. 400 times 1 is 400, times 2 is 800, times 3 is 1,200. 1,200. Let's jump ahead. 400 times 7 is 280, or 2,800. 4,000 or 400 times 8 is 3,200. So I'm thinking it's going to be the 7 because this is bigger than 400. So I'm going to use the 7. We'll start there. 7 times 0 is 0. 7 times 3 is 21. Carry my 2. 7 times 4 is 28 plus 2 is 30. 5 minus 0 is 5. 1 minus 1 is 0. 2 minus 0 is 2. So I have a remainder of 205. So I'm going to get 7 in 205 over 430. However, I'm not done yet. So I can divide 205. I can divide both of these by 5. And so 5 goes into 20. And I'm going to do this. I'm going to write this as 7. 5 goes into 20 4 times. And then it goes into 5 1 time, so 41. 5 goes into 430 8 times, or I'm sorry, 43 8 times, because 8 times 5 is 40. So it goes in 8 times. And I'm left with 30 left over. 30 divided by 5 is 6. Again, you could also do the problem to the side and say 205 divided by 5. You could do it this way and say this is 4. Having a hard time writing up here. Let's try this again. Well, let me write up here. Oops. So I'm sorry, that's a 6. You can write it over here and say 205 divided by 5. It goes in 4 times. 4 times gives me 20. 5 left over, it goes in 1 time. That's how I was doing that in my head, but that's how you would get that 41, and the same thing with 86. All right. Wow, this is a long video. I'm so sorry. You're doing great, though. Let's hang in there. Last problem, just like the example we did before, okay? So it says in the example 4, there were 9,038 people on the ride that are riding the swing. What is the least number of rides possible? So it says, again, the problem was 301 foot swing at 301 foot high swing at amusement park can take 64 people on each ride. A total of 8,983 people ride the swing today. All the rides are full except for the last ride. How many rides were given? How many were on the last ride? So we're doing the same thing over here, except for instead of using the 8,983, we're going to use 9,038. So I'm going to take the 9,038. I'm going to divide it by 64. We'll see what happens here. So 64 goes into 90, goes into 90 1 time, gives me 64. Going to make the 9 into an 8 and make that 0 into a 10. 10 minus 4 is 6. 8 minus 6 is 2. Bring down my 3 here. Okay, again, 64 is kind of like 60. So 60 times 4 is 240. 60 times 5 is 300. So it's kind of up to us how we want to do this. I'm going to go ahead and go with 4. It looks like there's enough room we can do 4. We'll see what happens. 4 times 4 is 16. Carry the 1. 4 times 6 is 24, plus 1 is 25. Ooh, just made it. going to subtract. The 6 I'm going to have to borrow from, make it into a 5, and make the 3 into a 13. 13 minus 6 is 7. And then the rest cancel out, bringing down my 8. 78. So 64 goes into 78 one time. So 1 times 64. I subtract, and I get a 14. So I have 14 here. So in this case, you're asked what is the least number of rides possible. It's not asking you how many people are on the last ride, so just the least number of rides possible. Well, we have the 141 where it's filled, and we have the one that has 14 people on it. So you could say the least number of rides possible is 142 rides. All right. I promise you, with all of my conviction, they will never be this long again. This just happens to be a very long section. You guys did a great job. The good news is you have no homework with this that you have to do at home, unless you didn't finish this set of video. You'll do your assignment in class the following day. So thank you very much for your attention. You did a great job. And you know you can always see me during class, and I can help you, or you can see me during flex. All right, thank you very much. Have a good one, guys.